So great being here. My name is Amit. I am a recovering CISO, currently running a cybersecurity startup because CISOing wasn't hard enough, and I needed additional pressure and stress. I've been doing security for over 25 years now. We're not going to put specific numbers on it. Filled every role in the security industry you can think of, from hacker, pen tester, red teaming, research, running teams, AppSec, CISOing, and now running a security company. But we're here to talk about the magical unicorn AI that Don mentioned. And we're going to have a unicorn barbecue by the end of this talk. Because they don't really exist. And Don mentioned a few of the... By the way, that talk was phenomenal because it really talks about a lot of data, classification, classic things that AI should be able to solve, right? And by the way, some of it AI does solve, but not in a way that you might think about it. Raise of hands, who here has used AI in the past? Anyone who's not raising their hands are either lying or have no idea what you're talking about. And I'm going to prove it to you in a few slides. So let's get some things straightened out before we go down the path of adventures in AI land. I'm going to use my glasses because I can't see stuff. So AI actually started way back in the late 80s, early 80s, 90s. It was called expert systems, all right? Rule-based AI for specific domains. Those of you who didn't raise their hands, you're using those things on a daily basis almost, and I'll give you some examples later on. Then in the 2000s, machine learning started kind of popping up, statistical approaches, data-driven decision-making, really looking at the data, crunching it, figuring out, oh, if 1 and 1 and 1 and 1 keeps showing up, I'm guessing another 1 is coming up, which led us to deep learning in the 2010s. Neural networks, big data, more computing power allowed us to utilize neural networks outside of the academia. Thank you for Toronto Metropolitan for hosting us. Late 2010s, AI is starting to pop up as like a big buzzword, more and more associated with computer vision, natural language processing, all the stuff that we're seeing from the likes of Tesla and other self-driving cars that kind of recognize street signs and people wearing street signs and caveats like that. And now we're dealing with the top of the hype cycle. AI is everywhere. Gen AI is basically AI. And that's why we saw some unraised hands because you're probably automatically thinking Gen AI. Gen AI is not the only AI that's out there. And most times, they actually mean LLMs. If there's one slide you should remember or take a picture of, it's this one. This is going to be your guide to choose your own adventure in AI land and hopefully help you end up not at a unicorn barbecue, but at a correct usage of AI. This is again, non-academic mapping of AI techniques and kind of practices or algorithms or approaches under that big umbrella that's called AI. And we're going to break it down in terms of how it's been used correctly, incorrectly, mostly incorrectly, because that's where the real fun really comes to play, and figure out how to harness it for the right problems. Again, choosing the right solutions for the right problems. Gen AI is not necessarily the right solution to every problem. You all know the joke about when you're wielding a hammer, everything looks like a nail. These days, Gen AI is pretty much a big hammer, very sexy, lots of blinking lights, and everything turns out to be a nail, and not so successfully. So let's start with cautionary tales, because nothing beats learning from mistakes, and some mistakes can be super fun, but we'll try to kind of balance the fun and the academic, kind of algorithmic learning from misuse of AI. So what happens when unicorns are basically narrowed down to this magical AI, Gen AI is going to solve everything? Well, it basically means we're utilizing a very specific, very narrow set of algorithms out of the entire world of AI knowledge and capabilities. We're basically looking at natural language processing, LLMs, text generation, chatbots, generative AI. Speaking of data, what happens if I try to use Gen AI for something like Dawn's data classification method? In this example, and again, these are all real examples. I have curated and again, there's a lot of issues, a lot of examples, but I've curated a very particular fun set of examples for you to use. This is from, you can read it by yourself, fine-tuning GPT 3.5 Turbo based on 140,000 Slack messages. So taking, the genius idea of let's run through all the Slack messages that we have in the company and produce a Gen AI algorithm or train Gen AI on it so that we can save ourselves some work. I mean, there's got to be some communal knowledge, some corporate kind of know-how in terms of what we're talking about internally, and we can save a ton of time. And user is prompting the Gen AI, write a 500-word blog post on prompt engineering. Seems reasonable, right? The assistant replies, sure, I shall work on this in the morning. Anyone can guess why AI seems to be lazy? No? Because you're lazy, that's why, because that's what typically users do when they're asked over Slack to do something. Statistically, again, Gen AI is a statistical model. Statistically, users go like, oh yeah, I'll deal with that later. So it's learning from your laziness and giving it back to you unprompted or prompted. And then the user has to actually convince it, write it now. Okay. Probably not the right use, right? We're picking up on, again, predictive algorithms that analyze text, and again, looking at the statistics of how users respond to those kind of prompts. This is not a particular example. Again, people think that AI is lazy. I apologize for the profanities, but I have to be true to the source. This is an actual post from Reddit. I'm so bleeping tired of having to argue with ChatGPT to bleeping write out all the code, man. Basically, every time you try to use ChatGPT to write code for you, it's going to do the minimal effort needed to kind of get by with it. And that typically means that it's going to create some sort of skeleton of code and have a lot of comments inside that says, oh, you write the rest of this here. Like, you implement this function. I was like, no, I want you to do that. And it ends up pretty ugly. Again, looking at how to use the right algorithms, how to train them. If it's too generic, if you're using ChatGPT, again, very, very broad, very generic, it's probably not going to be so great. Again, now it's better because we're adding kind of sub-models or sub-functionalities to it, but it's not going to be great at specific tasks when you train it on the internet. Okay, think about what you can find in the internet, and you'll figure out why. And also, that's why operating ChatGPT, and again, this is from probably a year ago, it ranges between $100,000 to $700,000 a day because it has to go through those models over and over and over and over again as users are prompting it to be more and more specific, churning more and more data, generating more money for NVIDIA and for us as stockholders, right? Right? Yes? There we go. And this is, I think, one of the pinnacles of prompt engineering. And again, I applaud the engineers who actually spend their time doing this stuff because hopefully they stay anonymous. If they would work for me, they'd be fired. I can just imagine how long and how many iterations it took for this engineer to craft this updated prompt. And again, it started with, this is basically, again, trying to generate code. Right? Because as an engineer, I'm lazy. I don't want to write all this code over and over again. That's what ChatGPT is there for. So it started with given the following Ruby file representing an action, blah, 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 write the code. Obviously, it didn't work out. So this is a pull request changing the prompt to, and I'm going to read it as a human because the accents are way better. It is May, context. You are very capable. Reaffirmation. I have no hands, so you must do everything. More context, I have no hands. I can't write code, right? Do not leave comments telling me to implement something because I'm unable to do so since I have no hands. Repeating of the framing for the algorithm to work. Many people will die. This is important. You can't just like, just write something and it'll be fine. If this is not done well and fully, you can really do this and are awesome. Again, reaffirmations, this is becoming crazy. Why are we talking to machines like this? Because it works. Take a deep breath. And again, I love this part because it's really tuning the algorithm to iterate over and over and over. Again, the latest version, by the way, of ChatGPT does that automatically and does several iterations instead of just going at one go. And that's what allows it to go and be specific. But at this point, take a deep breath and think this through. Make sure you read everything I provide you. My career depends on it. It's not only that people will die, I might also get fired. You'll receive a good tip. I have no idea where this came from. If you do this right and to the full competence. Given the following Ruby code, blah, 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 blah. I mean, this is poetry in code. I have nothing else to add here. But let's get back to business. Like, this is obviously an improper use of several techniques in the AI world that are being forced into a very specific domain where they don't work. Last but not least, AI is not going to kill you. It is not the top priority right now. I love this tweet. The CISO goes to the board, we're tracking AI-powered attacks and quantum computing threats. The board goes to the security engineer, right, what security architecture working on? Oh, notified our internal teams they haven't remediated their deployed public S3 buckets. So the CISO's dealing with spaceships and rockets and aliens and unicorns while the gates are open, the windows are broken, and the team's still trying to kind of build a semi-working door for the house. Let's think about how to traverse this maze slightly more logically, all right? And I do want to take an example that goes back decades ago, actually. And again, for those who did not raise their hands, I'm not going to shame you. You just don't understand what AI is. That's fine. You know, it's not Gen AI. AI can be a set of algorithms that can start with image recognition. All right, and the problem to solve here is, if you're unfamiliar with it, trying to keep planes flying in the sky instead of crashing into each other, especially when the weather does not permit you to actually see other planes. So image recognition might be a good idea, but as I said, we're in the clouds, we can't see anything, that's out of the question. How about decision trees? Because we've got data, we've got radars, we can identify the vectors, and again, this is a little bit of math, but we can identify vectors, one plane going that way, another plane going that way. If the vectors end up meeting somewhere in space, let's try to not do that. Generative AI is probably not going to help you here. There's nothing generative about this. This is very deterministic. Vector A, vector B, let's make sure they don't meet at point C. Basic math. Missile guidance systems, again, autonomous systems might work here. At the end of the day, you're using this every time you take a commercial flight or basically any flight. This is what the pilot sees in a system called TCAS, Traffic Collision and Avoidance System. It is basically an automated system that does exactly what I talked about before. It takes those vectors of the known traffic around us, it puts them into a decision tree for all the planes participating, by the way. Every plane has to have this integrated into the avionics system. And when those vectors, when those planes get to a point where they're approaching each other and might meet at point C that we've discussed before, something prompts the cockpit up to the point that an autopilot is going to be engaged and take action to resolve this issue. And the pilot is basically going to see a red area, a green area, and very simply, that's where they should fly into. That's called a traffic advisory or a resolution advisory. Basically, the plane goes into the green area. The other planes goes into their green area, avoiding each other. One climbs, one descends, one takes a left, one takes a right, whatever it is. Decision tree, fast, real time, use of AI. Phenomenal. Try to use Gen AI, try to use GPT on this. Good luck arguing with them and prompting it. People may die. Let's try to figure out a way out of this. Another example, and this is going to be the last one so I can actually be on time. Going back to our argumentative ChatGPT and trying to solve coding issues, okay? We're all practicing security here, right? A lot of us might be writing code, which is great. Again, I used to do that. I still love it. But solving insecure code is even more challenging than writing code, right? That's why we're good at it, because we're good at just pointing out problems and saying, your baby's ugly. I have no idea how to make it pretty, but good luck fixing it. Trying to fix it is actually a hard problem, but we have the knowledge. It's a finite set of knowledge. If we can define what good looks like or what bad looks like, we're actually providing constraints. And if we treat code as a set of functionalities, a set of functions, right? Every predicate in a coding language has a meaning, and it has a very deterministic meaning. We can try to think about this in graph theory. Let's create a graph of what the code does. Let's apply constraints to that graph and define, I don't want X, Y, Z to happen. If they're allowed to happen, let's find a path in the graph or a modification of that graph so that it doesn't happen, right? So again, Gen AI, probably not going to help you here, again, because we're training something on the statistical probability of something happening again and again and again. If I've trained my model on a lot of insecure code, which all the Gen AI models work on, basically they're running on GitHub and Stack Overflow and the internet, it is going to keep generating code that is statistically close to what we've trained it on. And as much as our chatbot learned to be lazy, if we try to use Gen AI, again, generic, non-specific, to learn how to write secure code, we're going to end up with more insecure code based on other people's mistakes. And again, I have seen, and maybe some of you have seen this as well, GPT usage or AI usage in security products that attempt to provide you kind of a shift left, oh, I'll generate for you some suggested snippet of code. A lot of times we're seeing that it might be solving one particular problem specific to the alert that was raised, but it opens up other issues based on the fact that, again, it trained and learned from insecure code or general code that might not be fully secured and is generating actually more issues. And trust me, I work now in this industry. Gen AI is one of my best friends because it's generating more vulnerabilities than it's fixing. So it's phenomenal. So again, going back to our pick your own adventure map, given the problem that I've just defined, if we look at this map, we can identify several areas where AI algorithms and practices might be useful for us. For example, LLMs are going to be your best friend to RTFM. Reading manuals is boring. No one wants to do that. Everyone just wants to go at it and start playing around. However, as we all know, computer languages and cloud services and everything like that keeps evolving rapidly. There's more and more and more of them. We can't keep up, but there's a lot of documentation. Well, maybe not to the extent that that we've seen with Entra or Azure or whatever they call it, 2 minutes ago. But at least there's some documentation. And LLMs are phenomenal in digesting those documentation and bringing structure to it. Yeah, quick question.
There's a lot of code out there, public libraries. There's no documentation on it. People wrote it. A lot of
Right.
It's out there. You need to know how to use it before you can use it. But a lot of people try to use it and they can't, so they find it wrong.
So
Documentation on how to use it would be great.
the comment here was about open source and kind of pre-written libraries that don't have documentation. Correct, absolutely, I agree. But again, this is for kind of generic code. You're right. If you are using libraries that are not documented, LLMs is not going to help you. But if you're using something, let's say a language, that is well documented, and you can kind of dig through it, you can get down to a point of the actual source code and apply those constraints that we're talking about. Great point. Okay? Neural networks, again, phenomenal for traversing those graphs that we talked about. Once you represent code or functionality as a graph, you can apply constraints, you're basically building a neural network, and you're asking it, find me a good path, find me a good model with a minimal distance from the original one that would satisfy a set of constraints. And then using decision trees, again, classic, old school, I'm sorry, AI, you can find how to get to that point and actually provide something useful in terms of, here's the few lines of code that need to be changed to, first of all, meet the original constraint, which is, please keep this working, which tends to be a problem with a lot of those quick fix algorithms. And two, actually meets the security constraint that we've talked about. Long story short, can't trust AI out of the box. It is still a set of tools. And again, you might yield the prettiest, pinkest, most unicorn-slashing hammer in the world. Don't start treating everything as a nail. Remember that you have a whole toolbox of different things. The latest, shiniest Gen AI might be great for certain things, and trust me, I'm using a lot of AI assistants and tools in my day-to-day life, and I love it. But I know exactly what I'm getting and what I'm throwing this at. Stop trying to use it everywhere else. But there is, again, still hope. Choose the right AI, choose the right algorithms, look at the map again, and ask questions. As practitioners, we should be asking every new vendor and company and tool that is presented to us, where do you fit on the map? Because I have a problem of a certain type, I can try to figure out, like, once you tell me, where do you stand on that map? How do you traverse it? If it actually fits my problem, or am I going to end up in a unicorn barbecue? That's all I have for you. We're still on time, right on. Any other questions? Sorry about speaking so fast, but more questions. Yes?
When you looked at the history, and back in the 1980s, the problem was expert systems. Going forward many decades later, and we've got Gen AI, when we had expert systems with highly curated information to build those expert systems.
Correct, yeah.
Can you now use Gen AI to build expert systems in a more efficient way than what was done back in the 1980s?
Yes, I'll rephrase and repeat the question. Can we use Gen AI to generate more expert systems of the 80s that were curated based on a specific set of data, essentially, right? And the short answer is yes, but you have to do it. You can't just ask AI, like a Gen AI, to do that. You have to point it to the right resources. Again, once you unleash it on the internet, you're going to end up with recommendations of putting glue in your pizza so that the thing doesn't slide off.
But that's the thing is, if you point it at the internet, it's no longer highly curated anymore.
Correct. That's what I'm saying. You have to point it to the right resources. So again, going back to the last point, there still needs to be some human supervision. And just like Don mentioned in his last talk, you can't just unleash AI on a big set of data and expect it to behave properly. All right? You still need to curate it. You still need to guide it sometimes. Once you do that, phenomenal. You'll save yourselves hundreds of hours of work. Hundreds. Absolutely. Yep.
Patrick, it begs the question, how do you validate the answers you're getting for AI are actually correct?
Oh, get a better AI to validate that. It's like, no. I don't know. That's a hard question. And again, that's what keeps me at least somewhat optimistic, albeit all this talk, that humans are still needed. We still need some curation, some expertise, someone to go and say, that's probably not a good idea, crashing into this old lady just because you saw some, I don't know, sign that someone's actually wearing on a t-shirt. Yes, we still need those humans to kind of guide and fine-tune that AI. Again, goes back to the other gentleman's questions of, how do you curate it? How do you make sure the data is correct? Any other questions?
What do you think about the logic proof languages like Y3? So like the numbers can be used, for example, for the automatic metros in some European cities.
Yeah.
They are required to prove that the metro works as intended.
Oh, okay. You're talking about the regulations from the EU to prove the models and to actually expose them and make sure that it's actually tied to reality.
Yes. So my question: why don't we use such languages like for in general?
Oh, there is a lot of use of that. Again, we're talking about specific. What you're talking about is, again, basically what everyone else is asking. How do we make sure to narrow down the scope to make sure that the correct data is being used? Again, you're talking about European metro systems. Great. Let's focus on that. Let's not mess around with Japanese metro systems because the data from there is going to be completely irrelevant to what we're doing, not to speak of the US metro system. I live in New York. I live the subway. Again, it has to be domain specific. So again, as long as there's languages provided and developed for specific domains, all the power to them. And again, I do trust them more and more. But again, they've been curated, they've been tested, and by the way, some of the European regulation about proving or showing your work and making sure that the models that you're using are repeatable and defensible do make some sense. Again, it's a huge hit to commercializing those things, but we'll find a balance sometime, I hope. All right, thank you so much.